Today's objective is to explain why protocols are necessary to overcome the underlying unreliability of the internet. A pretty big objective, but actually a short lesson. The internet is inherently unreliable. Wires can get cut, connections can get flooded with data, routers can crash. How can you ensure that a person receives the message you send? In this lesson, we will investigate how packets and protocols to structure them can make the unreliable physical network appear to be reliable to people using it. Think, Write, Share. What can packets do? Can you know in advance the path a message would take between you and another computer on the internet? Justify your answer. So what I'm doing right here is just showing you an example of what an exemplary answer would look like based on a question like this. So the question, one more time, can you know in advance the path a message will take between you and another computer? So you could say no, you cannot know the exact path a message will take. See, right here you're rephrasing the question. Because the most efficient route between two computers can and will change depending on which other routers are online and how much traffic is going through them at the time the message is being sent. So your think, Write, Share. What about this answer makes it exemplary? Packets are small chunks of information that have been carefully formed from larger chunks of information. So TCP, when I think of this, I think of TC packets, okay? But it's actually transmission control protocol. And what this does is it provides reliable, ordered, and air-checked delivery of a stream of packets on the internet. TCP is tightly linked with IP and usually seen as TCP/IP in writing. Think, Write, Share. In your own words, what are packets and what is TCP? Limit data loss. The internet is not actually perfectly reliable. Even in the modern day, a small percentage of packets, about 2%, are lost in transmission. We would prefer to only have to resend small chunks of data rather than the entire message. So that definitely will increase the efficiency of getting online. Think, Write, Share. What is common percentage of data that gets lost through transmission across networks? And then improve speed. Once a message is broken into packets, those packets do not have to travel from sender to receiver over the same path. If a faster route opens up mid-transmission, the next packets can switch paths. Efficient network usage. The total traffic across the network can be more easily balanced across routers if messages have been divided into smaller, more manageable chunks. So two great reasons right there to break things up into packets. And I ask, Think, Write, Share, why is chunking data into packets helpful? Alright, so another Think, Write, Share connecting these terms with their definitions. TCP/IP model, protocols and services. So this is good for you to see where TCP falls based on other things you've learned, like IP. You've learned about HTTP, a little bit about DHCP, and then of course you have an Ethernet cable here on the physical layer. Just a great diagram of how computers link up just so they can send packets. So there's a request to synchronize, and then the synchronization acknowledged, and then the acknowledgement of the synchronization being sent back. Since packets may arrive out of order, additional data must be included to indicate the order in which the packet should be arranged. Thus, while individual packets cannot be guaranteed to arrive, eventually an entire message can be accurately reconstructed. What happens if a packet is received out of order? DOL, Part 1, please write out the answer for clarity. So it says choose two, pick the two statements about packets and routing on the internet which are true. So this is your typical type of multiple choice question you may see on the AP exam, and they may ask you to choose two on there as well. This one, do not worry about writing out the answer because it's an example of what's not true. So I'm sure you've heard this from teachers a million times, but when taking a test, really look for the not word. It'll be nice if it's in all caps like this. So which of the following is not true about packets?